Hi, my name is Xavier Caderel, and together with my colleague Robert Crawford at the University of Melbourne, we wrote this paper titled Greenhouse Gas Emission Performance of Cross-Laminated Timber Construction Using Hybrid Life Cycle Assessment. And next time I make it shorter. When Australia represents only 0.3% of the global population, we generously received after the Paris Agreement 1% of the IPCC global carbon budget. What this means is that if we want to stay under the 2 degrees temperature rise, Australia should emit less than 10,100 megatons of CO2 equivalent from 2013 to 2050. With a national 2030 target of reductions of the greenhouse gases emissions of only 26 to 28% on the 2005 levels, Australia will spend about 85% of its budget by 2030, leaving very little emissions available for the following 20 years. With an estimated 30 to 40% of global greenhouse gases emissions associated with buildings, and the manufacturing of iron, steel, and cement responsible alone for 9% of these global greenhouse gases emissions, this means that conventional construction materials have large on-body greenhouse gases emissions, and so alternative materials should be considered. In the past 10 years, an alternative material called CLT or cross-laminated timber has been implemented in diverse projects around the world. It is an engineered wood product composed of layers of solid timber glued together, with each layer oriented at 90 degrees to adjacent layers. There are numerous publications comparing the greenhouse gases emissions performance of CLT construction versus conventional constructions with diverse methods and results. However, the lately released EPIC database from Robert Crawford et al. With hybrid coefficients for 284 construction materials is an opportunity to implement a comprehensive approach to greenhouse gases emission performance of CLT construction. So this paper uses the hybrid coefficients from the EPIC database to compare the greenhouse gases emission performance of a case study CSB constructed out of CLT versus a reference building RB constructed out of conventional materials, aka reinforced concrete. This paper does focus only on on-body greenhouse gases emissions, referring to the EN 15978. This study covers only stage A1 to A5 relating to product and construction. This case study building is a 4-story multi-residential building with car storage, lobby, a retail space at ground level, then 13 apartments on 4 levels. It is located in Thornbury, in the northern suburb of Melbourne, Australia. And it is a real-life case study. This building is being constructed as I speak in this end of 2020. We can see here the podium using reinforced concrete, then the 2 first levels using CLT. So regarding to the final result, the difference in total on-body greenhouse gases emissions for the CSB and the RB for stage A1 to A5 is 4.7% in favor to CLT construction. Now, this difference might look small, but it represents a saving of 95.22 tons CO2 equivalent. It might still be difficult to understand what it means. So, we are in Australia and our favorite scale is driving around the country. So, if we consider this type of vehicle, 220 grams of CO2 is emitted for each kilometer traveled. And so this 4.7 represents driving around Australia about 29 times. Beyond the final result, this study offers other findings. While the on-body greenhouse gases emission associated with main materials are 18% lower for CSB compared to RB, this difference is reduced to 4.7 after considering construction and minor materials. Quantifying the greenhouse gases emissions associated with construction and minor materials requires an estimation of cost for each materials. And so, it has been found that the greater variation in the costing of CLT compared to the costing of concrete can affect the final result with a variation of plus and minus 2.8% for the CSB total on-body greenhouse gases emission. Now, when looking at the greenhouse gases emissions related to main materials for CSB and RB, it makes sense to observe a single bar for CLT attributed to the CSB, the case study building. It is also coherent that concrete is much lower for CSB compared to RB. However, we can observe that the greenhouse gases emissions regarding to steel is quite high in CSB compared to RB. When looking in details, we note that the greenhouse gases emissions associated with concrete reinforcements are much lower for the CSB compared to the RB. But regarding hot rolled steel, the greenhouse gases emissions are about 2 times greater for the CSB compared to the RB. The greenhouse gases emissions associated with fasteners and brackets for CLT construction are negligible. This is another finding from this study. Looking back at floor layout, we can notice few load path descriptions requiring structural steel beam. For example, here we are level 2. Now, on level 3, those walls are bearing walls for the 4th floor above, and so this load must be transferred through this 3rd floor, since there are no bearing walls on the 2nd level. Unfortunately, this load exceeds the strength capacity from the CLT floor, and therefore, in this case, 6 steel beams 300 PFC are integrated to reinforce the floor and transport the load path. Finally, this case study building has been designed following the DIM to satisfy of the NCC 2016, making all CLT panels encapsulated by plasterboard. As a result, the greenhouse gases emissions associated with plasterboard are more than 2 times greater for the CSB compared to the RB. To conclude, this study, using hybrid coefficients from the EPIC database and a real-life case study, has shown that CLT construction can have a lower on-body greenhouse gases emissions compared to conventional construction during stage A1 to A5. It has been also highlighted that further clarification regarding to costing, and in particular CLT costing, could increase the accuracy of final greenhouse gases emission results. Designing with consideration of load path and CLT strength capacity could reduce greenhouse gases emissions related to steel for the CSB. And finally, further research regarding to CLT behavior under fire could reduce reliance on plasterboard and associated greenhouse gases emissions. Thank you for watching. It was Xavier Caderel. I'm looking forward to this conference, and I wish you all the best for this end of a very peculiar year. Thank you. Bye.